This is example 7 in section 7.3 on compound events. So this was one that gave us a little bit of trouble. So I'm going to talk about how to solve this type of problem. So in this one, we are given the probability of these three events, and we've got to find the probability of one or neither or both happening at the same time. So there are a few different ways that you can think about this. If you are visual, you want to draw a Venn diagram, we could draw a Venn diagram. We could think about sets if you want to think about unions and intersections. So I'll show you a couple of different things. So first, let's start with part A. We want to find the probability that at least one, the husband or the wife, has a college degree. So in terms of sets, we're looking for the union of the set that represents the husband having a college degree and the set that represents the wife having a college degree. So we're kind of including everything that's in either one of these sets. So we want the probability. Let me give these two sets names. I'll just call the husband set H and the wife set W. So we need the probability of the union of these two sets. So that would be the probability that the husband has a degree plus the probability that the wife has a degree. And then we need to subtract the probability that they both have a college degree. And that's just because it's already included in the other two numbers. That's easier to see on the Venn diagram. So we draw a diagram here. The overlap between these two sets is 0.5. And so what's left in the husband set is not the whole 0.65, because we want all of it, all of my blue circle here, the total of it to be the 0.65. So if we already have 0.5, do we just want the leftover over here? So just the 0.15. So together, 0.15 and 0.5 make the 0.65. And so similarly, over here, we want the total of that whole red circle to be 0.7. And we've already got 0.5. So what's over here would really just be 0.2 or 0.20. So the reason that we have to subtract the 0.5 in this approach is that this is the overlap, so it's already included in the 0.65 and the 0.70. Okay. So we took the probability that the husband has a degree plus the probability that the wife has a degree minus the probability that they both have a degree. And that will give us the probability of at least one. Put it in the calculator here. Okay, so this gives us 0.85. Using the Venn diagram, if we didn't want to use the equation at all, and we've already figured out the numbers here on our diagram, from this visual, we would need to add all three. So we would add the 0.15, the 0.50, and the 0.2, and that would also give us the total 0.85. So the solution for part A, the probability of at least one having a degree is the 0.85. So let's look at part B, and let's see what's the probability that neither of them have a college degree. So neither of them having a college degree is the complement, in terms of sets complement, of at least one having a degree. So we know that, I'm trying to write an equation here. So the probability of neither is the complement minus of the probability of at least one. And a complement we would take away from the total space being one. We would take away the probability of at least one having a degree, and that's what we calculated in part A. So we could just subtract that from 1 or 100%. And that's going to give us 0.15. We could see that in the diagram. Let's see, we had 0.15, 0.50, 0.2. And so in my whole space here, the total should be 1. And what I have labeled on my diagram so far only adds up to 0.5. So what's left over or what's outside here, so complement outside of these sets, would have to be 0.15, because they all need to add up to 1. Now in part C, we want the probability that only the wife has a college degree. So wife has a degree, but husband does not. And my first instinct was always to say, well, they told me that in the problem. They told me the probability that the wife has a degree. But that is also including, so up here is information that includes both of them having a degree. So we can look back at our diagram that we drew. Draw it again. And our answer is there. It's the part that is only on the wife's side. So not including both or this overlap here. So not including the middle part, only the part that's in the wife's circle. Which is the 0. That's equivalent to thinking that we're taking the probability that the wife has a degree minus the probability that they both have a degree. So the probability of the wife minus the probability of both, that would only leave, that would take out the part of that includes the husband. So that given to us that 0.70. This was 0.50, and we subtract them, we get the 0.20. All right, next I'm going to do example 9, and this one is similar, except we're not given any numbers or for any probabilities. We're told how many people are in this group and how many people are selected, and we have to find all the probabilities. For this problem, we need the notion of events being mutually exclusive. So this means that one thing is happening, then the other one cannot be happening at the same time. So an example would be flipping a coin. If I flip just one coin, then there's no way for me to get both heads and tails at the same time. So if I flip the coin and I get heads, then I definitely didn't get tails. So the probability of flipping heads, probability of flipping tails are mutually exclusive. One of them is happening, the other one is not. There are no common outcomes, and in terms of set, the intersection is empty. So there's no intersection between these two events. All right, so we want the probability that both of the people chosen at random from this group are men, or they're both women. That they're both men, or both women. That would be the probability that we choose 2 men plus the probability that we choose 2 women. So probability of both men plus probability of both being women. And how do we calculate those? So this was shown in an example in 7.2, equally likely events. So we need to find some combinations like we did in chapter 6. So we can use some of those counting methods. So we're going to take the number of outcomes of interest. We're going to divide it by the total number of outcomes. So the way that we can choose 2 men out of the 7 men that we have in our group, that will give us our desired outcome. And we're going to divide that by the way that we would choose just 2 people out of the total 12 people. So out of everybody choosing 2 people. Right? So we would do something similar to calculate the probability of choosing them both women. How many ways can we choose 2 women out of how many women in this group? 5. So we've got 5 women and we're choosing 2. We're going to divide that by just choosing 2 people out of the whole group. Right? So we'll calculate these and we just add them together. That will give us this probability. So if you like to use the formula and do it by hand, you can do that. If you got a calculator that has a button for this, use that calculator. Right, but 7 choose 2 will give us 21 possible ways. And 12 choose 2 give us 66. So this will also be 66. And choosing 2 out of 5 is 10. So I'm going to add them together as fractions. Since they have the same denominator, I can just add the numerators. And the instructions didn't say anything about how to give the answer, so really you could just leave it this way, leave it as fraction. Or, you would do top divided by bottom to get a decimal. The fraction is more accurate, especially if, and you do your division, you end up with a decimal that does not stop or repeat, then the fraction is more accurate. If you have to round it, then you're losing some accuracy. So the fraction is more accurate. All right, so let's see if we can get part B. We're looking for the probability that at least one is a man. So this is the complement. At least one man is the complement of them both being women. And we have already found the probability of both being women. Probability of at least one man. For the complement, we're going to take our total sample space of 1 and we're just going to subtract the probability that we choose 2 women. So 2. All right, so we just calculated that as a fraction. It was 10 over 66. If I want to subtract from 1, then I just need to rewrite 1 so that it has the denominator that I want, which is 66. So 66 over 66 is 1. But now I can subtract it from 10 over, well, subtract 10 over 66 from it. And that'll give me 56 over 66. And I'll just reduce it a little bit because I see common factors between the top and the bottom. I would just be able to divide them by 2. So I get 28 over 33. That is the probability of choosing at least one man from this selection.